centuries of trial and errors. They are not only yield results, but also cultivate critical thinking and creativity when used appropriately. As we gather here today, I encourage every scholar, innovator, policymakers, and students to all reflect on how this technology may leverage not only to drive innovation, but also to promote inclusion, not just to develop industries, but to empower intellects. The development of human capital flourishes best when people have access both the technology and to the knowledge of how to use it effectively. Let this conference be a forum for dialogue and inspiration, a convergence of ideas and collaboration. We come together to share insights, the challenges, the status, and the transformative technologies, and envision a future where science benefits and sustain humanity as a whole. In closing, I wish to leave you with this word of Sagan, the NASA astronomer, that said, somewhere something incredible is waiting to be known. Let us embark on this journey with wonder and determination that at the end of it all, we all go home with something special and something that we'll be able to use in developing our research ability. Thank you, and I wish all of us productive and inspiring conference ahead. Thank you.
We can do more than that for our Dean, the Dean College of Engineering, Professor Olamide Olusoya. We appreciate you. We thank you for that address. Ladies and gentlemen, for our students, learning is not attained by chance. It must be sought for with ardor and diligence. And I want to encourage our students that you can learn a lot from this conference today. That is why you have to pay attention and even write as we listen to our speakers. Thank you. In following the schedule of activities, ladies and gentlemen, Bosch University of Technology is now known for academic excellence. But there is a man whose leadership and vision have been instrumental in shaping our institution's academic excellence. Ladies and gentlemen, it is a man that we call with a standing ovation when he is called to give a keynote address. Dear guests, ladies and gentlemen, join me to welcome our distinguished Vice Chancellor, a fellow of Nigerian Society of Engineers, with the standing ovation, please, to welcome Engineer Professor Jeremiah Ojojowo to give his keynote address. You are welcome, sir.
Thank you. Please be seated. Thank you. Well, distinguished ladies and gentlemen, permit me to embrace the already well-established protocol by the MC and all the others. Sometimes I find it difficult sitting on protocol for the fear of it collapsing. And more often than not, people stand on it. And when they stand on it, it gets tired and might complain. And we task for someone to at least embrace it. So permit me, ladies and gentlemen, to embrace protocol so that you remain alive throughout this Icasit 2025. So, ladies and gentlemen, permit me to welcome all of you. It's an honor and privilege to welcome you all to the International Conference on Applied Science and Innovation Technology, fondly called Icasit 2025. I would like to specially extend heartfelt welcome to our esteemed keynote speakers who are well seated here today, our panelists who are amongst us here, industry leaders, and also policy makers who are here today. I welcome you all. Bells University of Technology, fondly known as Bells Tech, was established July 2005 to produce technically proficient graduates, ethically grounded, and globally competitive. Therefore, this conference exemplifies our mission of fostering rigorous inquiries, promoting practical solutions, and translating knowledge to the benefit of society. Ladies and gentlemen, Icasit 2025. Over the next 4 days, we will explore how scientific tools empowers human capital development, transform economies, and uplift communities around the world. Ladies and gentlemen, human capital is the lifeblood of sustainable development. The theme of this conference, the role of scientific tools in human capital development, is opposite, it is relevant, and honestly, it's coming at the best of times. And it is also, it helps to explore how scientific tools can enhance the quality and accessibility of education, improve health outcomes, drive workforce readiness, foster entrepreneurship and innovation ecosystem that translates research into products, services, and jobs. And finally, also to support evidence-based policy making and resilient governance. Distinguished ladies and gentlemen, we stand at the intersection of two places: rapid technological advancement and global imperative to invest in human capital, recognizing that equipping people with the right scientific tools and skills is key to driving innovation, growth, and sustainable development. Ladies and gentlemen, the tools of science extend beyond laboratories and equations. Let me digress a bit here. While some of us were going through schools in the past, we were taught triangles, Pythagoras theorems, and so on. We were in the laboratories with permanganate and other acids, titrating them. And honestly, through those periods, you wonder where you apply these things, what they stand for. Therefore, the conference of today is to ensure that these scientific tools are properly utilized, that these laboratories and equations are catalysts for decision making, equitable opportunities, and lasting prosperity. So, ladies and gentlemen, when skilled minds employ these tools, it unlocks human potential in ways that transcend any single discipline. Distinguished ladies and gentlemen, as a university, therefore, We aspire to be a living laboratory where knowledge meets practice. And that's why we are a University of Technology. And we are committed to investing in state-of-the-art laboratories, data-enabled classrooms, collaborative spaces that unite students, researchers, and industry partners. Ladies and gentlemen, I invite you, therefore, participants, to approach the conference with 3 commitments: that you engage generously, act decisively, and then elevate others. These 3 things will make this conference worth the while. So therefore, ladies and gentlemen, let us embark on these 4 days with ambition tempered with humility. Ambition tempered with humility, grounded in ethics and aligned with the well-being of humanity. Ladies and gentlemen, let me acknowledge that our discussions should therefore spark practical collaborations, nurture talents, and accelerate the development of human capital through the intelligent and responsible use of these scientific tools. Ladies and gentlemen, let me appreciate all of us. The organizing committee, led by Engineer Ibrahim Amale, we appreciate you for having worked tirelessly to bring this event to realization. And my special thanks will go to my students and other faculty members who are here, who are an embodiment of curiosity, resilience, and the pursuit of knowledge. Ladies and gentlemen, I wish you all a productive and inspiring Icasit 2025 conference. Distinguished ladies and gentlemen, once again, so welcome you to Icasit 2025 here at Bells University of Technology Water. We are only the best. It's good for Bells, and we are only the best can come out of Bells. Thank you. God bless you.
Ladies and gentlemen, we can do more than that for our Vice Chancellor for that wonderful keynote address. Let's join our hands together once again for our distinguished Vice Chancellor. We appreciate you. We are honored to have you today. Ladies and gentlemen, we want to make this conference a launch pad for ideas, innovation, and global connections, because it is an international conference. And from Africa to Europe, to Asia, to Australia, we have participants, we have authors who will be presenting, and it's an avenue for us to learn. Once again, we appreciate our distinguished Vice Chancellor. Thank you. We want to begin this extraordinary journey, and it's about the first business of the day. And following the schedule of activities, we want to invite our first guest speaker, who will be giving us his lecture. Ladies and gentlemen, I want to respectfully invite Engineer Dr. Oluwagbenga Emmanuel A. Ajiboye to step forward as I read his citation. Engineer Dr. Ajiboye, kindly step forward, sir. Thank you, sir. Engineer Dr. Oluwagbenga Emmanuel A. Ajiboye is a dedicated, visionary, and astute engineer whose quiet but impactful leadership continues to shape Nigeria's electricity future. A highly respected figure in the Nigerian electricity supply industry, he currently serves as the Executive Director, Transmission Service Provider, TSP, at the Transmission Company of Nigeria, where he leads the strategic delivery and operational readiness of critical transmission infrastructure nationwide. His work ensures that power generated across the nation can be safely, reliably, and efficiently rolled to millions of Nigerians. Let's clap for him for that. Engineer Ajiboye is a scholar practitioner with a remarkable academic portfolio, holding a PhD and MH in electrical and electronics engineering, alongside master's degree in information technology and business administration. His career progression through key leadership roles in TCN, from Egbin to Lagos region to TCN headquarters, reflects deep technical expertise, operational excellence, and transformative leadership. A proud member of CORIN, the Nigerian Society of Engineers, and the Nigerian Institute of Management, he has championed capacity development and knowledge transfer across the sector, participating in advanced international technical trainings in India, France, UK, China, and ABB facilities globally. Let's clap for him for that. Beyond systems and infrastructure, Engineer Ajiboye is passionate about people, actively nurturing talent, fostering technical capacity, and supporting sector-wide competency growth. His exemplary service, commitment to professional excellence, and strategic contributions to Nigeria's power transmission development attracted an award by the Chartered Institute of Mentoring and Coaching, Nigeria, CIMCN. Ladies and gentlemen, join me to welcome Engineer Dr. Oluwagbenga Emmanuel Ajiboye for his lecture. Let's give him a round of applause as he comes on stage. Thank you, sir.
Good morning, ladies and gentlemen. Good morning, my VC. Let me stand on already established protocol. Yes, I'm here to represent Engineer Ajiboye, who is not available. And where's the slide? Okay. So, I'm here to represent Engineer Dr. Oluwagbenga Ajiboye, who is indisputable, and the topic is role of scientific tool in human capacity development. And the focus will be on Transmission Company of Nigeria. As you all know, Transmission Company of Nigeria is a company saddled with the responsibility of wheeling power from the power plants to the distribution networks. We all know that most of the power stations are sited where the load cannot be consumed. Therefore, we need transmission company to wheel the power to the end user. So the way and manner the company is being run to develop human capacity using scientific tool is what we are going to discuss. Okay. As introduction, scientific tools are used to reshape how professionals learn, innovate, and carry out their work. In transmission company, we have networks that we rely on so many scientific tools to deliver our deliverables. We have a lot of modern tools that we are using, which by the time we go on, you will see what we are talking about. And all these things are being driven by human beings. And that's the reason why the company lay emphasis on developing human capacity. For us to understand human capacity, building technical competency through training, research, and skill enhancements. The core areas in transmission are basically the system operation, where the dispatch is being done, the protection and control and metering departments, the lines. You all know that we have a lot of pylons along our networks that convey the power from the power plant down to the distribution network where the household will take their supply. Then is a sure thing for us that we must maintain our equipment, because once there's issue, large area will be disturbed without supply. That is why maintenance is key to our operation. Planning and expansion, that is, we have to plan for new areas that are coming up, and our project execution. All these things are what is essential for us to take care of. And we are using so many scientific tools to drive all these mentioned. You know that it's not easy for us to do anything in present day without scientific tools. Look at the core areas we are talking about. If you are talking of equipment, most of the equipment you see nowadays are software based. A typical engineer in transmission company must be computer literate, because there's nothing you want to do without the knowledge of software. I'm happy that Bells University, there are so many basic programs that are embedded in the curriculum. The last time I was here, I discovered your students are doing Python and so many other software that are being used in the industry. Going further, all these analysis that you are going to do, if you are talking of power flow, dig silence is part of what you can use for power flow. PSSE, ETAB, these are things you use for your simulation when you are doing your power flow study. We all know that in power flow, you must be computer literate, because there are so many iterations that you will need to do when you are doing a lot of things during power flow. When you go into testing, after installation, you need to do what they call pre-commissioning test. That is where you see a lot of equipment coming in. In the past, you can, if you want to do a test on transformer, you may need about 20 test equipment. But with science-driven, you have one equipment, like the Omicron. The Omicron, you can use it to do a lot of tests on a power transformer. Is encompassing, and it depends on the way you want to do it. And I can assure you, with this, you achieve what you need and you are home and dry. The Mega, for those of us that are electrical engineers, we know that Mega is a company name, but they have so many products that they use in doing their tests. If you look at Mega, you do a lot of tests, insulation resistance of your equipment, you do it there. Now, come to SCADA and EMS. SCADA and EMS, what does SCADA means? You do supervisory control and data acquisition. There's no way you will do control and data acquisition that you don't need scientific tools. These are things that are done in TCN. Energy management system. There's no way you manage your equipment without having all these scientific things. We use the GIS mapping. Before we start our project, we need to map, we do the survey of the area where we are bringing in new projects. I can announce to you that we have a project that is not too far from you here. We call the town Ajegunle. We are trying to put a 330 substation here, and all the GIS location mapping and everything has been done. We do a lot of simulation, and we use MATLAB, Python to do our analysis, which are things that are being learned in the university here. The link between this scientific tool and human capital. You know, in the school, you are taught theory, but by the time you come to the field, you know, for those of us that are in electrical engineering, we do transmission line, T network, pi network. But I can assure you, by the time you come into Transmission Company of Nigeria, if you are in protection, you will find it easy, because of what you are taught here, to do a lot of simple calculation on how to set the protection on your line. Because all these are pylons that you see around, we have a protection on it. Once there is fault, the protection will be triggered. And with the help of scientific tool, I can assure you now that once the protection trigger, you can easily know from the fault location on the relay, the actual area the problem has happened. These are modern things. When we joined the organization, all these ones are not in existence. We were using electromagnetic relays that you need to carry so many boxes. You have so many boxes when you want to test. But with the advent of all these modern scientific tools, you can do your tests within a twinkle of an eye. And with this, my executive director, who owns the lecture, just completed his PhD program in this university, and his thesis is based on transmission losses. Engineer Mole, I think I'm okay, I'm right? So if you look at what is happening now, human capacity development is based on what we are talking about. Scientific tool is what is using to drive. In our training, I can assure you that we have a simulator that when you have transmission line, all these are our capacitance resistor that we do change on transmission line. If you go into the lab, you can easily change these values and do your simulation, get what is expected. And with that, you cannot forget what is expected of you. And you get to know our system planning department, they use Dig Silence, PSS. After doing the load flow, they will tell you what and what is expected of you to do your line, and how and where you can get your line parameters. All what you are being taught are things you will see in these softwares. The protection and control and metering, the energy meters, you can stay in your house with the connection of your internet. You can read the value of the energy meter right from your sitting room. The protection and control too, all our relays, all the protection relays on the network are connected via optic fiber, and you easily download everything you need. These are part of what we are having. The training, we have a lot of simulators that you can use, and I believe with this, so many things that you are taught in school will be easily explained when you come into the simulation lab. The impacts, we don't need to take 2-3 days when we are looking for faults on our network. By the time the protection relay operates, you can get the fault location, and from there you deploy maintenance people to go and restore the circuits. Our maintenance, we have a lot of software that we use in doing our maintenance. The predictive one, the one we do annually, these are software driven. We are no longer using manual way of doing things. They are all software based. By the time if you are supposed to do a maintenance today, 2 days to that time, it will prompt up on your network that you have a maintenance, and are you ready for the maintenance? All these things are being fed back into the system. And that is why in the grid now, the grid is being managed accurately because of some of this modern software. The SCADA EMS program, they are still on it, is not covered by all the network, but at least is feasible to certain extent, and all these things are making things easy for us. Safety and reliability, we have a lot of scientific tools that we are using on that one too. You cannot just enter the switcher without accessibility. All our network, you need access code before you can enter our network. Now, the challenges. You know that all these software were developed by experts. So, license to this software are very costly. And that's part of the challenge we are having. For you to get some of this software, you pay through your nose. And I believe those of us that are using some of these software, we are aware how much it costs. Then, another issue that is a challenge is the number of lab that we have. As I'm talking to you, the standard lab that TCN has is only in Lagos and Abuja. All other places need to move down to those locations if they need to do some of these items we are mentioning. Another problem is shortage of experts. We know that some of these things are just coming into existence, so we don't have enough personnel to do the training for people that are coming. I've mentioned the other one, cost of this equipment. The Omicron that I'm talking to you about, in 2020, when TCM bought the first set, it was around $20,000 US. Now, I believe it will be more than that. So those are the little things that is depriving the organization to get to where we expect to be. Now, another issue we are having, when you are coming up with this technology, you know, people that are used to, that is the way we do it, they find it difficult to adapt to modern technology. But the method TCN is adopting is that if you are not ready to move, we'll leave you behind. And that's what we've been doing. Way forward. How to integrate these two into our curriculum. Another thing we notice is how to strengthen TCN with university partnership. We know that so many of our staff do some of this program in the university, but the collaboration is not there, because some of this research work, what is expected is for us to implement some of the things that are being done in the university. So, way forward, we are looking at a situation where the company will partner with a university and they will drive some of the things that is needed in that university. Invest in digital infrastructure. Most of us are not ready to invest in digital infrastructure because of the cost. And We believe with time we don't have option because most of the things that are going on in the world are digitalized. So if you are not ready to move, you will be where you are. Promote indigenous innovation. If you look at the crop of professors, doctors, engineers in this country, I believe we should be able to do a lot of things without bringing in so many foreigners. So these are things that we believe can help us get to where we are going. Encourage certification and retraining. I can tell you that some of these equipment that we are talking about, we need to do recertification. Some are 2 to 3 years. Like the Omicron now, the recertification, you need to send it to Austria if you want to do recertification on that equipment. So those are things that we feel we should set up a standard lab in Nigeria where all these recertification on some of their equipment will be carried out. Strategic benefits. By the time we are able to get all these things done, you will have skilled workforce enhancements, system reliability, better power quality, timely project execution, and regulatory compliance. We all know that in Nigeria, NAC, the Electricity Regulation Commission, is the one that is regulating the sector. So they have so many laws that you need to abide to before you can move in. And there's a lot of transition program that is going on in the power industry. The Electricity Act of 2003 has given a lot of states to develop their own markets, their own system operation, their own transmission company, and their own distribution company. So the transition entails you using scientific tools for you to get to your destination. So if we don't want to be left behind, we need to adopt this. In conclusion, you can see that scientific tools turns knowledge into competency, because something you are supposed to do for hours. I could remember when we joined the system, if a 330 kV line trips, sometimes it do take our maintenance people 1 week to trace the fault. But with the modern relays, the relay will give you the location, and from there they will take off and bet you they will get where the fault is. The other one is success depends on the people trained to think, simulate, and innovate. And as I've said earlier, we all need to invest in people for us to develop our infrastructure. I thank you all for listening. Thank you very much.
Ladies and gentlemen, we can do more than that for Engineer Dr. Ajiboye for that wonderful lecture and well management of time. Has been able to manage the time very well. We want to appreciate you for that wonderful delivery. We have listened to what aligns with the theme, the role of scientific tools. And our guest lecturer has told us different scientific tools that we need for human capacity development. The technical skills, the conceptual skills, the managerial skills that we need as an engineer. And also for the data analytics, whether it is predictive data analytics, whether it is descriptive, whether it is prescriptive, or whether it is descriptive. There are different scientific tools for all these data analytics. Once again, let's appreciate our guest lecturer for wonderful delivery. Thank you. We are trying to manage time, and because after this ceremony, we'll be having technical sessions in the afternoon. And that is why I know we have questions. Am I correct, students? We have questions for our guest speaker. And after all the presentations, we have the time for questions where our erudite speakers will be able to give us answers to them. But in moving forward, we want to proceed to the next lecture. Ladies and gentlemen, let me invite Engineer Oluwafemi K. Ajiwole to invite the second speaker and to give us the citation of Engineer Professor Adefemi Adekunle, who will be our second speaker. Let's put our hands together for Engineer Ajiwole as he steps forward to give us the citation of the second speaker. Thank you.
Thank you, sir. Good afternoon, everyone. Permit me to call on the guest speaker for today to please step forward for his citation to be read. Professor Adekunle was born in Ede, in Osun State of Nigeria. Formerly, he was working with Reynolds Construction Company during the construction of Ogbomoso-Ilorin Expressway before joining Ladoke Akintola University of Technology, Ogbomoso, Oyo State, in the Department of Mechanical Engineering and as an academic staff, and later proceeded to the Department of Mechatronics, Federal University, Oyo Ekiti State, Nigeria, as a senior lecturer. He had his BTech degree in mechanical engineering at the Department of Mechanical Engineering at Ladoke Akintola University of Technology, Lautech, Ogbomoso, Oyo State in 1999, and thereafter proceeded to the Federal University of Technology, FUTA, in Ondo State for his Masters of Engineering in Mechanical Engineering with a PhD grade of 3.73, which made him to pursue his academic career at the Federal University of Agriculture, FUNAB. Please put your hands together for him. He graduated from the Mechanical Engineering Department of FUNAB with a 73.3% aggregate in PhD Mechanical Engineering production option in area of artificial intelligence and mechatronics. Please put your hands together for him. An enthusiastic holder of doctorate degree, PhD in production engineering, registered with Council of Regulation of Engineering in Nigeria, COREN, member Nigeria Society of Engineers, MNSE, corporate member MIEEE, Robotic and Automation Society, corporate members of South Asia Institute of Science and Engineering, MSAISE, corporate member of American Society of Science and Technology, MAASCIT, corporate member of International Association of Engineers, MIAENG. He possesses the ability to work well under pressure and meet tight deadlines. He has attended many international conferences, both locally and internationally. Please put your hands together for him. He has shared many sessions in international conferences and has been reviewing for many international journals. His research interests are in the area of computer-aided engineering, such as computer-aided design, CAD, computer-aided design and drafting, CADD, computer-aided manufacturing, CAM, computer-aided planning and programming, CAPP, computer integrated manufacturing, CIM, automation, robotic, artificial intelligence, manufacturing engineering, machine tools, production operation management, and knowledge-based expert systems. Adekunle has about 20 years experience as a lecturer and administrator in the university. He is an assiduous worker, a motivator, an innovator, an academic achiever. He has contributed to international development of and maintenance academic curriculum development, staff development, and capacity building programs. As an erudite scholar and a prolific writer, he has a great wealth of research experience which culminated into over 80 academic publications in international journals, peer-reviewed conferences, proceedings, and technical reports, etc. He has graduated 2 PhD students, supervised 6 master's students, 8 postgraduate diploma students, and over 100 undergraduate students. Please put your hands together for him. He was the pioneer HOD of mechatronics engineering in Federal University of Ekiti, top-up conversion at the same university, former deputy dean of postgraduate school, former director of international linkages and collaboration at FUE, and currently a member of governing council at Federal University of Ekiti. He has an excellent personality with stable emotion and physics. He has also served creditably well in many university committees. He has served as members of both NUC and Korean acquisition teams. Please put your hands together for this gentleman. Professor Adekunle received international award in mechatronics at Chicago, USA in 2024 by First Eye Concept as a renowned innovator in mechatronics field. He is happily married with wonderful children. Please, ladies and gentlemen, put your hands together for this award-winning professor, my professor, our professor, the guest speaker for today, Professor Adefemi Adekunle. Please put your hands together for him as he comes to the stage.
Thank you very much. Like my boss said initially, I want to stand on the existing protocol, but I pray it doesn't break. It's a pity there has been problem with network. I had challenges with network. I was trying to send my PowerPoint to the man in charge there, but it was not going. Incidentally, I sent the PowerPoint through WhatsApp message to Dr. Amole in case he could be able to give it to them over there. I will never bother us at all with this presentation, and that was why I planned having some kind of videos that are supposed to explain much more better than the paper we have before us. This research in this area is very germane. And if you want to go by virtue of what we are doing today, we are really empowering masses, students, and what have you. I want to give honor to God for being here today. The Icasit 2025 has come and it is going. I want to appreciate the organizers and my powerful VC, who happened to be my father and my grandfather. He was my HOD at Lautech, and he brought me up as a student union leader. But mind you, I don't have to put that my office as union leader in my CV up to today, because it was not a very good experience. So if you are a union leader, please desist from it. The relevance of this theme is a very good topic, and it will bring a rapid technical change to the whole world. What is tool? What's a technological tool? I want to borrow from the speakers what they have just said regarding tools. As we have, there are some things that are in place now that is making life to be much more easier for us. I was trying to use Google like 2 or 3 months ago. Eventually, the Google that I've been using before, taking me through where there will be normal road, it will be giving me where there will be hold up and the likes. Mind you, Google was taking me into the river, to pass through the river with my car. Is that possible? Is that okay? Which means tools have advantages and disadvantages. It depends on how you want to make use of it. Scientific tools are not only lab instruments and engineering hardware, but they are much more useful for us, like AI, digital twins, simulation, biotech, data analytics, and the likes. All these things, if you take them together, we can simulate and project what we are expecting to do in terms of developmental exercise. And then, all these tools extend the reach of human intellect, enabling us to model complex systems. What is a complex system? A complex system is something that we feel if we want to go by virtue of ordinary intelligence, we can't achieve anything there. But by going through our technological tools, we can achieve whatever we want to do. What of human capital? We mean aggregate of knowledge, skills, creativity, competence, and innovative capacity embedded with individuals and society at large to make things work out for us. Then the nexus between scientific tools and human capital. For example, each student is expected to come out in flying colors. And when they teach you to go by virtue of this way, you are to go through your own personal intelligence to add more to whatever you want to gain as your own intelligence. So, scientific tools accelerate learning, expands research, and upscale workspace. It's not good. Thank you. Yeah. The historical perspective of this research. I will go through one little story. There was a man working with a Ford company. Ford is where we have these 4 coats. And the man was a layman there, an apprentice. But he now saw that they were using machine to pull off hairs from the animals. So what he did was like, okay, if they are putting off this one like this now, how do they go about it? He now said the machine that was being used to pull off the hair from the animals, from the goat and sheep, he now fabricated that machine, and then he did it in such a way that it will be used to mow grass. Do you know what we call horsepower? 1 horsepower, 2 horsepower, 3 horsepower. How do you come about all these things? After this man made that machine, there's no way he can be pushing the something. So he had to push the machine to be cutting the grass. So the machine will be in his front. But eventually, they were now disrupting the flower and other things. So it means it was going away from where it's supposed to be cutting the grass. The man said, how can we go about it? Instead of you using your power to push this machine, it now wants to get us. So the us will now be pulling the machine to cut the grass. So if one us now pulling the machine, that is 1 horsepower. So if 2 horses are now pulling the machine, that's 2 horsepower. So those power rating was now generated for all this cutting machine, all this AC and the likes. So historically, if there's no problem, there can be solution. And when we have a problem, engineers are there to make sure they solve that problem. I've talked about the Industrial Revolution, and let's go forward. The technical dimension for this research work or the presentation for educational training and then for business-wise. Every individual is here to make progress and to make contribution. So, in terms of technical dimension, the tools that we are talking about is of a various kinds. One, there are some that are being used in industries, And there's some that are being used for academics. Look at this now. This is a robotic farm watering system. It's a pity if it's the one that I wanted to send before. You will see the video being played. We have a farm, and for a man to be watering the farm, it might not be easy for him. We now developed a watering system which is being controlled by robots. It is autonomous. So if you don't put on this thing, it will be working, pumping the water while you are using your phone to navigate and push it forward, to maneuver it to anywhere it wants to go. So by virtue of that, we have resolved two problems. One, there's no noise pollution. Two, there's no labor loss, because that machine will be moving as you are controlling it. It will be watering the flowers either left or right, front and back, and then it is rechargeable. Research and innovation. Like I said, when we are talking about the research is something that you have to make sure you have a goal. When you have a goal, think of how to solve the problem. Look at the Michael Zuckerberg. The way it started with something very, very low. So, but eventually today, everybody is now paying money to him. So in that wise, for research, we take into consideration what are students going to gain from this research, particular research. But for innovation, you think of the environmental problem you want to solve. When I was at Lautech, there was this a lawnmower, the one I saw that I discussed initially. To the lawnmower, we want to resolve two problems. One, the labor market. If you have to call two people to work on your lawn. One, fatigue will set in. Two, peradventure the person that wants to cut it won't cut it uniformly. So we now develop a lawnmower that's being used to cut the lawnmower to cut the lawn. One, the lawnmower is autonomous, so it has a rechargeable battery to be moving it. But along the line, we now saw that it won't be easy for us to use that one to cut for a long time. By the time the battery drains out, there will be a problem. We now develop another one, which is a solar-powered lawnmower. So by virtue of that solar-powered lawnmower, we can't be cutting lawn in the afternoon. We have improved on the previous one that we are talking about initially, which was the one being powered by horse. So there's high performance in computing with machine learning when it comes to tools that we are talking about. Look at this one now. If this robot plays, you will see that we have made a robot that will be concreting the floor. Instead of using a manual man to be concreting the floor. So this robot moves around to concrete the floor, and then at a very minimal cost. Apart from that, when he finishes his own work, there will be a robot that will be putting on slate, that is the tiling robot. Look at this one now. You can play it on the something. So what we are talking about is that for this one to come into play, there must have been some kind of background coding that will make it to work as expected. And therefore, industry and workplace, that's the technical dimension. For industry, they are gaining whatever we have produced for them. For example, we made a robot that will be cleaning the hall. That is an automatic vacuum cleaning robot. We have made a robot that will be, a firefighting robot, and then firefighting drone, and the likes. So in automation, robotics, and the hybrid skill, those are the area where technical dimension is now in vogue. And this robot, for a layman, an handicapped man, the man that can never walk at all, there was a robot that was made for him. Only what he needs to do is just to sit down in that machine, and that machine will now pull him up, and then he will be pressing the button left and right to make him move forward. the metrics of impact, skill acquisitions rate increases. The innovation outputs increase as well. We have patented so many things in this regard. And the case study is for engineering and mechatronics. They are the key thing that we work on this thing to make it lively for us. So the machine learning schedulers for HVAC fault detection. There's no way you will have a robot that won't have adverse effect, like I said the other time. So every robot has its own demerit. There was a robot that was developed one time. It was supposed to be giving man food and then drinks. But eventually, one of the codes got missing along the line. Instead of the robot to now give the food to the owner, when he got there, the owner just extended his hand to collect the food from the man. Guess what? The robot just slapped that man. He thought he wanted to fight him. So, which means it is even risky to believe in robot than man. We have robotic girlfriends. Do you know that? I'm serious. They've made the robot to be wife. So we are now becoming lazy day in, day out with technological advancement in the whole world. So these are twins, and then the robotic things and simulation. And finally, why I'm coming to an end, this was a robot that we developed, which is a autonomous robots too. This one was the one that we used to get award at US last year. So this robot, when you just open it, it will be moving front and back, left and right, to cut grass. By the time it senses that the grass underneath is green, the blade will be rotating. If it sees that it's not green grass, it won't rotate again. And by so doing, it will make things easier for us. But there are implications. Improved reproductively, transparency, sustainability, and then preparing gadgets for Industry 4.0. That's the robot I was talking about initially. Challenges and ethical issues. Digital device skills gap. There is a device skip. There is a gap in between the old technology and the recent one. AI bias and transparency. I would have loved to talk about one aspect of the efficiency of AI or the ChatGPT, but if I say it here, students will take after it and use it negatively, so I won't talk about that. Environmental footprint of computing, cultural and institutional residents. So, strategic pathway forward. Policy invest in infrastructure, open science, responsible AI, academic, embedded tools in curricula, that is, in simulation AI and digital twins, and then industry, co-create training, interscript, and the likes. And finally, global collaboration. We can collaborate with anybody via this scheme. Vision for the future. Immersive classroom and virtual labs. I will give the my department, one virtual lab where we can get access to all this kind of thing I was talking about. And then workforce defined by creativity and adaptability. So equitable, ethical, chill use, that is, close global gap. In conclusion, tools are bridges to knowledge. That is, when you have a tool, there should be a particular reason you want to make use of the tool and to achieve a particular set goal. For example, I would have mentioned somebody that thought he could use technology to reduce his age, but eventually he changed the blood, changed everything in the system, but he can never change the eye, the arms, and everything. So eventually, as things are decaying, it's now reflecting back on his own physical disability. So there is a way that we can circumvent around all these things. It is not a garbage in, garbage out. I was doing my master's, PhD one time. I gave my phone, my Oga told me to punch his own phone number on my phone. He gave me his phone. When I took the phone, I was trying to press 08033 something. If I press 8 will show. If I press 8, 2 will show. I was battling with that phone for like 5 or 10 minutes. The man was just laughing, smiling. I didn't know he was just trying to pull me, to pull my legs. Now, so have you put your phone number there? I said, I couldn't go. He said, that's the phone I'm using. You have to change it for me. This is where I'm going. There was a particular thing under that face that makes the phone not to attend to me. That is my functioning. Am I communicating, please? Am I communicating, please? So, which means something must be there. There are some phones, when you just look at them like this, it will open. If, peradventure, by the time you were doing facial recognition, the lady now used pancake or this powder on the face. And eventually, by the time he was trying to open the phone will just say, I don't know, you are an alert. Because it has changed the facial recognition of the person that was used to configure that thing. So what I'm trying to say is this. By whatever you are doing today won't be relevant by tomorrow. That is why every project I'm trying to do will stand test of time for the next 5 or 10 years. So that by the time they want to do it again or revisit it again, it will still be standing above sea level. And finally, I want to thank this organization for giving me the opportunity to present this keynote address. Thank you and God bless you.
Ladies and gentlemen, that is not enough for Professor Adekunle. Let's do more than that for him. Thank you very much for that insightful lecture. We appreciate you. We have been able to understand that even these days we now have robotic girlfriends, as Prof said. I'm sure we do not have any robotic girlfriend here. Thank you. Ladies and gentlemen.
Recording in progress.
It has been a wonderful day, and we have been able to listen to 2 speakers and trying to let us know about the theme, scientific tools. But I want to ask our students, are we seeing the importance of attending an international conference? Are we seeing the benefits of attending an international conference? We are gaining knowledge. You can also have the chance for collaboration. You are also networking. And I believe after this opening ceremony, you will also be present at the technical sessions, whereby you listen to speakers, authors across the world. I want to assure you, we have authors from Australia in this our conference. We have authors from Malaysia. We have from the United States. We are from the United Kingdom, and that is the essence of an international conference. There are some things you cannot get in the classroom. You have that chance to get it by coming to an international conference. And that is why, once again, I want you to clap for organizers of this international conference. Let's put our hands together once again for them. The reasons for attending an international conference, it will boost your career. For collaborative opportunity, networking benefits, and knowledge sharing. Because conference is a meeting point of ideas, expertise, and passion. As we try to manage time, please feel relaxed, because there will be opportunity for us to ask questions or clarifications. So our students should feel relaxed and should not be tensed. In following the schedule of activities, we have another guest speaker, that is Professor Yuan Sun. You can see it is truly an international conference. From Nigeria now, we are moving to South Africa. From Nigeria, we are moving to South Africa, and that's how it will be from now till Friday. Across all the continents in the world, we have presenters and guest speakers. Thank you. Thank you. While we are waiting Professor Yuan Sun to join us, because she's ready, she's with us. But while we're trying to prepare for her to join us, we want to open the floor for questions so that our erudite speakers can provide some responses. I know we are interested about robotics. We want to ask about data analytics. We are all researchers here. We are all doing research. Whether we are using descriptive analytics, you want to explain what has happened, or whether you are utilizing diagnostic. The question is, what are the tools for diagnostic analytics? What are the tools for predictive analytics? There are different tools for any of these analytics. And what are the tools for prescriptive? So, if you have any question on what we have listened to, we want to open the floor now for us to ask our questions before we go into the next presentation. Please, those who have questions should signify interest so that we can give them numbers. Thank you. From this side, any question? Any question for our speakers? Okay, our registrar is number 1. That is wonderful. Please clap for our registrar. Okay, while awaiting other questions, let's take the question from our registrar. Thank you, sir.
Thank you very much. My question goes to Engineer Akintola. Your presentations, you said that we have some sophisticated equipment for the transmission to detect faults and then to make repairs here and there. My question is that why do we have a constant grid collapse in Nigeria?
Thank you very much, sir. Please kindly note the question so that we can take from another participant. Thank you. I can see a participant trying to ask a question here. Over to you.
Sorry, sir. The registrar has just asked my question. The same question I wanted to ask.
Grid collapse, very important. Okay. Questions from our principal officers. Now is the turn of the university librarian. Thank you, ma'am.
Thank you very much. Let me appreciate the two speakers for a very well delivered presentation. I'm just like a little bit worried listening to the second speaker. You know, one would get excited that things are really going on in Nigeria also. That I want to say, there are all these innovations, like you showed us a lawn that is it lawnmower now? Yes, that is it AI controlled or whatever? And you said that it won an award in the US. Now that got me a little bit worried because we have had a lot of innovations like that, award-winning innovations that never got to the market. One would have expected that one day I will walk into one of our malls, maybe just using that hypothetically, and then I will see that lawnmower made in Nigeria. You know, there's what is our industry university collaboration that will make such products to be mass produced, such that we don't only depend on products that are imported. For instance, we have so many engineers that are doing so many things. Why can't I walk into a mall and then get a microwave oven that was designed from beginning to the end and then produced in Nigeria? Why do we always have to import? And my mind, you know, went back to some years. I was in a university, and it's the first private university of Agric in Nigeria. And they imported, the institution imported these battery cages for poultry. And the engineers there were celebrating that it was imported, and I was angry. And I was like, okay, you use 1.something billion to get this. I said, you just improved or boosted the economy of one country at the expense of Nigeria. So I want to say, are we less engineers in Nigeria than we are, you know, the engineers we have across the globe? What exactly is the problem we have that is making us just to have all these products and just win awards and then it dies. I'm a librarian. There are so many projects that have been written down on the shelf. Is that what we should be driving at this point? Just projects and then they will end up on the shelf and everybody is clapping. Thank you, sir.
Thank you very much, Ma. Any other question before? Okay. Let me now allow our guest speakers to respond to those questions. Engineer Akintola, over to you, sir.
Thank you very much, sir. Our situation in Nigeria is very complex. Some of these collapse we are talking about is caused by Nigerians. Issue of vandalism is a serious issue for us. Because in Nigeria now, most of the power plants we have, they are run by gas. So you now discover that our towers in the southeast, most times are vandalized. I could remember a situation where we fixed a tower that was vandalized, and the third day after it was energized, it was vandalized again. And they are not using it's bomb they use in vandalizing these our towers. That's one of the issues. The other issue, after privatization, gas pricing is in dollars. But before privatization, Nigerians are enjoying subsidy. Even, before privatization, the Genco, Disco are under governments. So they use government to do payment of gases. But after privatization, they were told to be buying gas in dollars. And they are not getting their money. So the gas companies sometimes cut off supply due to non-payments. And once this happens, the grid is run through demand and supply. So once the demand is more than the supply, there's always problem. And that's a simple way I feel I can explain. And when you look at it, I will give you a brief. We supply Benin, Niger, and Togo supply. But the little we supply them there, they are more disciplined than us. They manage it. But we, in Nigeria, we are always having issue with that. Recently, we are trying to do synchronization. And this synchronization, what we want to do is the West African line. We want to do like what the Europeans are doing. So we were able to synchronize and we ran it for 4 hours. And during the process, a line tripped around Côte d'Ivoire. But it was Nigeria that compensated for about 100 megawatts that went out during the synchronization. Because once you link the grid, power will flow to where it is needed. So, but basically our own problem is internal. It's not that the people running the grid are not there to work. But in a situation where, okay, another one that I will tell you that is closer to us, towards Abeokuta here, during the time this present government wants to take over, we lost about 10 towers to vandalization. And Abeokuta was out of supply for about 4 days. And is running towards May 29 when we are supposed to take over. And as at that time, I was to go on vacation. But my boss told me, if you are sacked, don't call me. Because they will tell you are trying to sabotage the government. How come is the state capital that will not have supply? But we were very, very close to Abeokuta. That was where they even used machine to cut the tower. 9 towers fell. So if you imagine that, I don't know how we want to go forward with that. So it's not that we are not there, but these are issues that we are having. As I'm talking to you now, we have about 3 or 4 towers that are down. And if you look at the cost for everybody that knows engineering, to do new project is far, far simpler. But when you want to do repair, you spend more and more stress because you have to consider so many things. Under this our line, they are not supposed to encroach it. On Sunday, we were doing one maintenance around the Ikorodu. They've built under our lines, and it's very difficult for us to do the maintenance. The line route that you're supposed to traverse for about 2-3 kilometers, we have to come out here, go in the other side, because people have built under the line. And we don't have the power to say we want to demolish. It's government. In fact, Lagos State government told us, if they want to demolish for you, they will do it before election. But once the election is coming, we are not going to demolish for you. You can imagine. So those are the kind of issue that we are. It's very difficult for us. It's always a difficult issue for us to overcome. In fact, sometimes you will say, which part of the world are you in? Something you know that can take you minutes, you now spend hours. If you want to walk on the road, we employ last mile, road safety, police, because by the time, we've had a situation where we are fixing the line, and the police advised us that we should come and do that line midnight. We started 12 midnight. Abule Egba here. We've lifted the conductor up to this certain level, and one trailer was just coming. The way we were shouting, stop, the man didn't stop, and the conductor cut his throat like this. We had to abandon the job that midnight, and the police, they took the vehicle away. By the time we came back around 12 noon, the vehicle is no more with the police. So there's a lot of issue that is surrounding this issue of our problem.
Thank you very much, sir. A lot of things affecting Great Collapse. Let's put our hands together once again for Engineer Kintola for that wonderful response. Ladies and gentlemen, we are about to switch from physical to virtual. Professor Winjashin is standing by to give the third and final lecture for today. But as we do that, let me invite Mrs. Deborah Daramola to give the citation of Professor Winsha. So please put your hands together for Mrs. Deborah Daramola as she comes on stage to give the citation of Professor Winsha. Soon we'll be giving us the third and final lecture for today. Thank you.
Good afternoon, ladies and gentlemen. Firstly, I would like to thank conference committee's invitation, and I'm honored to have this opportunity to present my work in this conference.
Good afternoon, Professor.
Can you hear me?
Professor Son, just 1 minute, ma'am. We want to read your citation. Just a minute to read your citation to the participants. Thank you, ma'am.
Can I come in now?
Professor Yanzian Shun is a professor of electrical and electronics engineering at the University of Johannesburg, South Africa. She holds a joint PhD in electrical engineering and scientific technical information from Tshwane University of Technology and the University of Paris, EST. Her research focuses on artificial intelligence, evolutionary optimization, renewable energy systems, and control engineering. Professor Son has published or accepted over 200 papers, successfully supervised 22 postgraduate students to completion, and received numerous national and international awards, including recognition as a world top 2% scientist at Xavier and Stanford University. She is actively involved with IEEE and the South African National Research Foundation has led 20 research projects as the principal investigator. Please, let's make welcome Professor Son to give her speech. Thank you.
Thank you, Mrs. Zaramala. Over to you, Professor Son. You have the floor now. Thank you, ma'am.
Good afternoon, everyone, ladies and gentlemen. Firstly, I would like to thank the conference committee's invitation, and I'm honored to have this opportunity to present my work in this conference. I hope you can hear me. Can you hear me?
Yes, we can hear you loud and clear.
Okay, thank you. And further computational intelligence integrates neural network, evolutionary computation, and a fuzzy system. It has educational value. It transforms algorithmic understanding into innovative thinking, and it also grows demands for optimization literacy in Industry 5.0. And it is also a scientific tool, not only a method, it is a mindset. And so we would like to train some engineers and researchers in these tools, build analytical and problem-solving capacity. And for evolutionary optimization, firstly, I would like to introduce what is optimization. So we can find the answer from this figure. Optimization is about making things better or more efficient. It involves finding the best solution from all possible options. You can see that who wins this and who will be the better option. And for evolutionary optimization framework, it includes a single and multi-objective optimization, and we also have some evolutionary optimization algorithms such as particle swarm optimization, genetic algorithms, differential evolution, and so on. Some others, and in my presentation, I will introduce two particle swarm optimization and genetic algorithm, and including some applications with the neural network. And for the hybridization improves the convergence, stability, and adaptability, some other advantages for the hybridization of the algorithms. We also need to understand the trade-offs cultivate deep analytical skills. So when I would like to introduce the evolutionary optimization, we definitely need to understand what the single objective optimization is and what the multi-objective optimization is. From the definition of single objective optimization, it will be easy for us to understand is that for this kind of optimization, it only involves one objective function. The task of finding the optimal solution is called a single objective optimization. For example, we need to find a car with the minimum cost, and the objective function is to minimize the cost subject to some constraints. Those are the constraints. G, X, I are the constraints. X, I are the variables. And so either it is single objective optimization or multi-objective optimization. We divide the system based on the number of objectives we need to optimize. This is one famous example of a single objective optimization, the traveling salesman problem. Given a list of cities and the distances between each pair of cities, the traveling salesman problem asks, what is the shortest route visiting each city exactly once, then returning to the start? This is a tough problem in optimization. It is non-deterministic polynomial time problem in combinational optimization. So just to give you one example, what is single objective optimization problem? And if two or more objectives need to be considered for optimization, then it is a multi-objective optimization. Real-world optimization problems typically include multiple goals, and those goals are usually in conflict. So for multi-objective optimization, there is one important definition. It is called Pareto optimal front. And we can see this example, and it has two objectives need to be optimized. We need to find a curve with minimum cost and maximum comfort. And so the objectives will be the minimum fxi subject to some constraints. There are two objectives need to be optimized. And for the Pareto optimal concept, we need to find all the solutions of U, all the solution of a Pareto optimal set. U is one solution of the Pareto optimal set. So that is U is at least as good as V for all objective function values, and it is better than V if for at least one objective function value. So that is all the values of U is called the Pareto optimal set. So this figure, first figure of figure 3 shows the Pareto front of maximizing the objectives of F1 and F2. So the second figure shows the Pareto front of minimizing the objectives of F1 and F2. So this is Pareto optimal set. Pareto optimal set. So evolutionary optimization is widely used in engineering optimization. In my presentation, I will introduce two evolution optimization algorithms, particle swarm optimization and genetic algorithm. Particle swarm optimization was proposed by Kennedy and Eberhardt in 1997. It mimics the behavior of birds flocking or fish schooling. The animals collaborate with each other to migrate or search for food. And the particles for animals that forage or travel in group or search for food, they make decisions with regards to movement often depend on social interactions among the group members, like this figure, figure 5, and the fish schooling. And the particles will update its velocity according to equation 1 and its position according to equation 2. And in those two equations, Vi represent the particles velocity at time t. Omega R1, omega C1 and C2 are constant. R1 and R2 are random values. Pi, the best position of the particle itself, and PG is the best position of the swarm. And then the particle will update its position according to equation 2. So Clark and Kennedy reformulated the equation 2 as this equation, And then we finally have the relationship of phi at yt, as shown in this figure, figure 6. It has the bifurcation like a dynamic in figure 6. This will explain why we would like to introduce chaos into our PSO structure. And the corresponding Lyapunov exponents, lambda 1 and lambda 2 are both 0 at the initial values of Vt and Yt. So for every value of phi, the value of y are only recorded after, so for this figure, only recorded after 100 iterations. And what is chaos situation is that we need to check whether the Lyapunov exponent, there is a formula for us to calculate the Lyapunov exponent. When the Lyapunov exponent value is greater than 0, then that means the system is in chaos situation. So according to the particle model 1 and 2, those two equations 1 and 2, what we proposed is this particle structure. And for this structure, one particle, we think that one particle of the particle swarm optimization can be considered as one neuron of a human being. So it can be connected with the artificial intelligence neural network, right? And there is a difficulty in verifying convergence theoretically. And with the characteristic of a whole field neural network, the convergence can be theoretically approved. So from this structure, we can see that this structure has feedback, which is the characteristic of a whole field neural network. Then we connect the particle with the artificial intelligence. And it also exhibits stochastic-like chaos, since it has random values, random R1 and R2. So we can consider that the particle structure also has the characteristic of chaos. And with those two characteristics, we propose the whole field neural network energy function given as equation 3. So it can be connected with the best position of the swarm and the best position of the particle itself. The whole field neural network has a property that as each neuron of a whole field neural network updates, energy function is monotonically reduced until the network stabilizes. So we can therefore map the optimization problem to a whole field neural network, such that the cost function of the problem corresponds to the energy function of the whole field neural network as the result of the whole field neural network, then suggests a low-cost solution to the optimization problem. So the particle will update its position like that. And for this one, Lipo-1 presented a convergence theorem for whole field neural network with an arbitrary energy function, and it is in discrete time dynamic. So the neurons will update the position like that, like equation 4. And for the whole field neural network, what we proposed in equation 8. In equation 8, is obtained simultaneously resolve the equation 3, the previous one, 3, the whole field neural network energy function, at 5, at 6. At the same time, equation 11 is obtained by simultaneously resolving equation 3, 5, at 9. So the position of the particles will update its position according to equation 6. And the related UI of variables can be updated according to equation 7. And similarly for the XIP and the UIP will update according to equations 9 and 10. For equation ZT plus 1, equation 12, is added to equation 7 and 10 for this one, for example, added to this equation to cause chaotic dynamics. Why I would like to have the chaotic situation is that you can see that from this figure. From this figure, we can see that lambda, the Lyapunov exponent is greater than 0 before 2000 steps and less than 0 after 2000 steps. And so a positive Lyapunov exponent is usually taken as an indication that the system is chaotic. This will help the particles to expand the search space in the objective space. So after the 2000 steps, the particles escape from chaos and gradually convert to minimum. We can see that the particles escape from the chaos situation and gradually arrive at the stable status. And through the whole field neural network energy function, we finally approve the convergence in theory. And you can see that the particles will finally converge to as equation 11 and equation 12. So we can observe that all particles' final states like this, and denoted by the circles, converge within or on this circle, At the center point, we can find it through MATLAB or Python, and also calculated in this figure. And through simulation, we also verify that the proposed method is quite useful for us for some real application like the pressure vessel, design a pressure vessel, or some other real application, and the performance is quite good. And the second paper I would like to introduce is about genetic algorithms and their application. So for the first one, I introduced particle swarm optimization combined with the whole field neural network for the real application. The second one is about the genetic algorithm. Genetic algorithms are the earliest, most well-known, and most widely used in evolutionary algorithms. Genetic algorithms are simulations of natural selection that can solve optimization problems. It is a search heuristic that mimics the process of natural evolution. And so this is it is called a gene of the you can see that a genetic representation of the solution domain and a fitness function to evaluate the solution domain. That is how a typical genetic algorithm requires. And this is called a gene, this is called a chromosome, and so this is called a population. So this is how it works, how the genetic algorithm works. the two parents have crossed over to produce two children at some point, at this point, the crossover point, and each child receives some genetic information from one parent. So this is from one parent plus this one from another parent. They exchange with each other. So this is called a crossover point. To implement the mutation, after the crossover, it will have two children, like A5 and A6. And after we have two children, to implement the mutation, we select a mutation probability C 1%. This means that after crossover process produces offspring, each bit in each child has a 1% probability of flipping to the opposite value. So the process includes initial population, fitness function, selection, crossover, mutation, and that is how the genetic algorithm works. This is an example of how genetic algorithm works to find the best position or best solution for objective. And this is the second paper I would like to introduce, maximizing demand response aggregator compensation through optimal renewable energy source utilization. And in this paper, there are 5 aggregators are used in this project. Demand supply operator will purchase power from renewable sources, like the solar farm of the energy market. It meets excess demand for end users during peak hours. In this paper, we assume that a renewable energy source utilized by the end users are the rooftop solar panels and plug-in hybrid electric vehicles with the vehicle-to-grid capacity. The aggregators then compete with each other for the most effective energy usage profile. The aggregator with the least energy demand wins the bid. And demand response aggregators are effective in maximizing both the capacity and energy gains for both end users and the distribution service, where it meets excess demands for the end users during peak hours by purchasing electricity from renewable resources of the energy market. And for this paper, a typical day is assumed to be a winter day in Johannesburg, in the city where I stay. For day-ahead scheduling, the consumers prevent their projected energy demands for the following day. The DSO or aggregators then take the demand and present them to market operators, who then provide an hourly cost profile for the day ahead in the DSO or aggregators. In this paper, we assume that both the DSO and aggregators are price takers. We consider the utilization of both battery energy storage system and the solar panels by this DSO. And end users use roof top solar panels and plug-in electric vehicles with vehicle-to-grid capacity. And in this table, it shows the electrical appliances schedule for one apartment. The aim was to maximize gains to both the distributed generation operation and the consumers based on both real-time pricing and incentive-based demand response program. while simultaneously minimizing the costs from the distributed generation. And you can see that what is the operating time scheduled for each electrical appliance. The DSO operating cost includes the power from grids. So I didn't give all the details. Power from the grids and the DSO operation cost and the aggregator cost and the end users cost. And the aim is of compensation optimization is to maximize cost benefit to the DSO. And so this is a multi-objective optimization. We need to minimize those two and minimize those two and minimize this one and maximize this one and maximize this one, and subject to some constraints. And from those figures, we can see that the end user utilization of aggregator at the renewable energy sources is more beneficial to distributed supply operators. That is more beneficial for the DSO. You can see that the consumption is less as time goes in a day. These are the advantages for evolution optimization. It's simple to be used and robust to be used, and we can get the answer quickly and easy to combine with other algorithms. And it also has some challenges that it is we need to also consider the dynamic environments and large-scale optimization problems. Maybe it depends on the performance of the evolution of each evolution optimization algorithms, and we also need to consider the highly constrained optimization problems, and also for most evolution optimization, if we don't connect it with the artificial intelligence, it's not easy for us to have the performance analysis in theory, and those are the challenges for us to consider. So for the human capital development through scientific tools, and we can see that we can firstly understand the theory and then do some computational work and do some simulation through the software and then apply it to the real application. And so we can do it through the coding, simulation, and research publications to improve our own impact, research impact. And we have the promotes the problem solving, collaboration with the other researchers, and self-learning capabilities. So the framework for the human capital development through scientific tools is like, firstly, we need to learn by ourselves and then apply, share with others, and also innovation is the most important. So that's all for my papers, published papers. And you can also see that evolutionary optimization function as both scientific tools and education instruments, and training optimization directly contributes to research capacity and innovation. Science plus human capital is a sustainable technology advancement. So I introduced two published papers for evolutionary optimization plus AI and plus the real application. That's all for my today's presentation. Thank you all for your patience with me. That's all. Thank you.
Thank you very much, Professor Song, for that wonderful delivery of your lecture. We really appreciate you and all your emphasis on optimization and the various problems you have been able to solve with the different models. We sincerely appreciate you. Thank you for your time. We are grateful. Ladies and gentlemen, we have just listened to Professor Son, who has taken us through optimization. Whether you want to minimize costs, you want to maximize profit, the different approaches you want to use, whether it is demand and supply, are you to use or you are to use the Virgin, or at what point do you use the northwest corner method? These are tools in optimization, and we appreciate for that wonderful delivery. Before our lecture, we have two questions, one from our registrar and the second one from the university librarian. And while Engineer Kutola answered the first question from the registrar, we pleaded with Professor Adekule to hold on for the end of the third lecture before answering that question. And I want to give the microphone to Professor Adekule to respond to the question by the university librarian. Thank you, sir.
Yeah, thank you very much. The question was that we have projects being taken to abroad for award and the likes, but over time in Nigeria here, we don't have it being commercialized. I like that very question. Let me say this categorically, that Nigeria that we have today, we don't appreciate what we have. That's the problem we are having. That is one. Two, it's a pity the video didn't show there, but I showed it to my powerful vice chancellor over here. Every project is meant to solve a problem. Whereby the problem is not being appreciated, there's nothing to be solved. I went to NDA Kaduna for accreditation as a member of the NUC team. On getting there, we saw what the students did. They did some robots that can be moving, but it can only be simulated to carry gun. Okay, I will send the video to you, sir. Eventually, I now told them that this is military zone. When I was there, I was given a soldier to be moving, to be piloting me, to guide me here and there. So I was not opportune to move around peacefully by myself. But, and I told them that you can improvise so and so into this project. It's now become a real robot. And it cannot go anywhere to shoot, to determine maybe this is an enemy or not. It was adopted, accepted, and it was done in such a manner. That is one. Two, I traveled in 2012 to Canada, to India. So a Part2 student was making drone from the scratch. And I said, if Part2 can do it in India, my project student in mechanical in Lautech Part 5 will do the same thing. So when I came back, I gave it to one guy. Baba Lucas happened to be our mentor. So I called this guy that let us make a drone. The first ever drone we are going to do in my lifetime was in 2013. So when we saw that drone, he said, "Oga, what are we going to do to this thing?" I said, "Let us disassemble this one and reassemble." So we now did that in that manner. So the only thing we did there was that when the drone reaches a particular height, it will crash land. And now say, let us program it to the extent that by the time it gets to a particular height and there's no power there to sustain there for so long a time, let's go back to the source. So it now reserves the energy to go back to the source. Let me say this, man. When I was leaving Lautech for Foye in 2015, that guy was going for service. I said, Afolabi, come to Foye, come and serve with me. I was there then. He said, "Oga, if I come there, would they be giving me 500,000 per month?" Money only, yeah? You understand? Because the money he was making as a programmer, as a student, is far, far, far more than what I make as a lecturer. In 2013, before I left Lautech, that guy and some a couple of boys, I trained them. So they went for competition at US. If you Google Lautech student represent Nigeria at USA X Imagine Cup, you will see it there. Lautech students represent Nigeria at USA X Imagine Cup. They got there, they won throughout the whole world. They went in 2014. Again, they won. So when I was now leaving Lautech for 4 years, and I told him, come and join me. He said, okay, I can't just join you because I can't make what I was expecting to make. Today, that guy is the one in charge of all the BRT tickets in Lagos State since about 3 or 4 years ago. It's the money. What I'm trying to say is this. The little thing we can train them with, we give it to them as a student via lecturer. But he now took it upon himself to develop himself more than expected. So whatever we can do, they can do better than us. In 2018 or 2019, I think Foye did one conference, first science conference. They brought a chairperson of FIRO to be a keynote speaker, where I was keynote speaker as well. In that conference, I told them, all these people doing BB Niger, doing this nonsense in a particular place to be given 100 million, it is bullshit. Why can't we have our students come somewhere, train them, give them challenge to solve, problem to solve? I never knew they would take it into consideration. So they took it upon themselves. They now camp about 30 or 50 students in a particular building. They did competition. They said they should write a program to solve a particular problem. They were not being evicted until they had 20 in the house. So those 20, they now said people should vote for them, like they used to vote for BB Niger and the likes. Let me say this. The first person was given 25 million. Second person, 15 million. Third person, 10 million. The person that won the 25 million for the first prize came from Lautech Mechanical Engineering, one of my brothers that I trained then. The third person, Pedro, became third, 10 million. I want to just say this, that as they are sitting down like this, whatever they can gain from whatever they are getting from this conference, they should just work on it and empower themselves. Lastly, ma, to answer that question of yours, it is federal government that don't appreciate technological advancement. Professor Adiroba was dean at Abuad. He called me to come and join them to build a drone, like a parachute or something like that. When we did that thing, we improved on it to make it like a mini plane. Today, if you go to that place, you will see that plane in front of their Senate building. We now went there last year as a member of governing council with my chairman and other people. When we got there, Baba saw me and said, Adekunle, how are you? Long time. Come and see me later. He now told my chairman that this was the plane that we did then, a couple of people that we did together. When we got to Oyo Ekiti, my chairman, governing council, Duma Egba, was just saying, so you can do something for outsider, you can't do it for insider. Then it means your input here is not well felt. It now charged us that we should go and make how to run that school on either solar or anything. So we won't be on grid because we are spending like 80 million per month on diesel. Ma, let me say this. If you need whatever is being showcased, tell the developer that please, I need this thing. They will produce to you, produce it for you, then you show your other people, they will come for it. That is how we can empower our students, our researcher, and the like. As I'm staying like this, I have a power station in my car that can carry TV for 5 hours, fridge for 5 hours, and what have you, because I know I'll be needing it anywhere I want to go to. So it's now left on the individual to support technology in that area. So thank you and God bless you.
Thank you very much, Professor Adepele, for that wonderful response. We are listening to responses from our first two speakers who are with us physically. I understand Professor Son is still with us. Professor Son, are you still with us, please? Professor Son, are you still with us so that we can just ask one question? Just one question for Professor Son. I want to confirm if she's still with us before we ask the question. Okay, I'm told she's with us. So Professor Son, if you are with us, I want to seek a clarification, because when we talk about systems, we can have a system with single input and single output. We can have another one with single input and multiple outputs. We have systems with multiple input and single output. And you have multiple inputs, multiple outputs. Based on what you have presented to us this morning, I want to ask, which optimization model can you advise us that will be able to cater for these 4 systems arrangements? That is just the question. Which optimization model will you recommend that can cater for these different systems arrangements? Single input, single output, single input, multiple output, multiple input, single output, and multiple input, multiple output. Professor Son, over to you, please, if you are with us. Thank you. Okay, while we... Professor Son? Are you with us, please? While we try to re-establish contact with Professor Son, I believe when she comes, she'll be able to answer the question. Thank you. All right. Moving forward, we have listened to all our speakers this morning, and we are honored to have our principal officers with us. At this time, it is our culture in Best University to always appreciate those who have come to impact us. And that is why I have that pleasure to invite our distinguished Vice Chancellor, Professor Jeremiah Ojedero, who will be making a presentation of plaque to our guest lecturer. Ladies and gentlemen, let's put our hands together for our Vice Chancellor.
Well, distinguished ladies and gentlemen, I think we have been treated to very good presentation today by these 2 or 3, 2 on ground, 1 virtually. The presentation have been quite insightful. I was quite glad when the registrar mentioned Greek collapse, and he told us the local problems that led to a Greek collapse. Honestly, quite a number of us have been wondering why we had this all over. Vandalization, the major issue that you cannot curtail except others do it for you. That shows the relevance of our topic today. If we are not listening, obviously there will be no question. Thank you so much for presenting that very well. We want to appreciate you. Dr. Ajibo wasn't around, but he sent in a round peg in a round hole. I think we should clap for him. So, on behalf of Bells University of Technology, want to, while appreciating you, thank you for being a very good representative. This award is an award of appreciation presented to Engineer Dr. Uluwabenga Emmanuel A. Ajiboye, the keynote speaker at Icasit 2025. Thank you for your well-presented paper, thoughtfully put together and well presented. Thank you very much. In a characteristic manner, this is an alumnus of this university. So well, say us well to him again. This is presented to Mr. Engineer Dr. Ajiboye. Well, he was telling me that he is also an alumnus. So well, the two alumni are doing quite well. We are proud of you. Thank you very much. Well, this next award is for Dio Kunta. That's the name we call him. Well, I'm glad he did not insert his student unionism day in his CV. Maybe I will have queried some things. And he left with an advice that please don't do that, because he almost lost his studentship while going down there. Well, how he was able to manage those two things together, student unionism and his academic work, beats our imagination, but you made impact nonetheless. Having come this far, we are very proud of you. So this is an award of appreciation presented to Engineer Professor Adefemi Adekunle, the keynote speaker at Icasit 2025. On the theme, the role of scientific tools in human capital development. Thank you for going down the robotics line. Thank you for educating us. And I hope you put this more into practice in the future. Thank you so much. You're not an alumnus, but we still give this to you.
Thank you very much, sir. We appreciate our Vice Chancellor for that presentation. While the third lecture was going on, or even the second lecture, we recognize the presence of the Dean, College of Natural and Applied Sciences, Professor Icasit. You are welcome, ma'am. Also with us is the Dean, I saw her not quite long, College of Environmental Sciences, Dr. Mrs. Orekon, the Acting Dean, College of Environmental Sciences. Let's clap for her, please. Ladies and gentlemen, I now humbly invite to give the vote of thanks our registrar, Mr. Lamidi S. Tafa. Thank you, sir.
Thank you very much. Distinguished ladies and gentlemen, we have come to the end of this first section of the program. And before we close, we have to express our sincere appreciation to, first of all, to the Vice Chancellor, Professor Jeremiah Oludele Ojediran, for providing the enabling environment for this lecture to hold. Thank you very much, sir, and we thank you for your able leadership. The bursar, Mr. Ashina Adepoju, thank you for coming. The University Librarian, Dr. Felicia Yusuf, we thank you most sincerely for coming. The host, the Dean of College of Engineering, thank you very much for the well-organized program, and we thank you and all your team. May I also thank all the deans here present, all heads of department, all professors, all staff and students of the Department of College of Engineering for coming to attend this program, and we thank you very much. Distinguished ladies and gentlemen, let me express our sincere appreciation to all the speakers of today for doing us proud, for coming to present this lecture. Let me first of all express appreciation to Engineer Dr. Ajiboye, ably represented by Engineer Kintola. Thank you very much, sir, for the lecture delivered. Engineer Professor Adefemi Adekunle, we thank you very much for coming to add, to contribute to knowledge through this lecture. Distinguished ladies and gentlemen, we thank you very much, and God bless you all. Thank you. I also thank Professor Song, who also participated virtually. Thank you, Professor Song.
Thank you very much, sir. Let's put our hands together for our registrar, Mr. Lamidi Tofa. Before we do the closing prayer, please, all authors should check their email. The brochure has been sent to our email because later today, by 2:30 p.m., the first technical session will be taking place. So authors, kindly check your email to know the order of presentation. Thank you. Let me now invite Engineer Surajuddin Babatunde to give us the closing prayer. He started with an opening prayer and we end with a closing prayer. Engineer Surajuddin Babatunde.
Bismillah, alhamdulillah, salatu wassalamu ala rasul kareem wa ala alihi wa sahabati ajma'in. I will give thanks to Allah subhanahu wa ta'ala for taking us this far. We give thanks to Him for making this possible for us, and we pray to Him to guide us through the remaining of the program for this week and even beyond. We pray to Him to make this a progress for us in our chosen career and the in all our endeavors. Subhanakallahumma bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilayk.
Allahumma ameen. Thank you. We now take the university anthem to be followed by the national anthem. University anthem first. Thank you. Let's be on our feet as our principal officers and guests take their leave, please. Thank you. Let's remain standing, please. let's remain standing and let's be orderly. Thank you.